In part 2 of question 2, we're going to update the table again, except this time we're going to use the on-policy method, SASA. So let's go over to the whiteboard. I'll just draw our original Q table again. And we're going back to 0.15 this time. And just as previously, we're going to get an updated value for this S1A1 pair. Let's just put these in now. Cool. So just like I did with the Q learning, I'm going to come down here and use the update rule for SASA. But there's one more piece of interesting information they gave us in part 2. We've got this random value 0.01. Now this relates to something up here in the text description of the question. We're actually using an epsilon greedy action selection method. And our epsilon value is 0.1. So the idea is that if we get a random value that's less than 0.1, less than our epsilon value, then we're going to randomly choose the next action with equal probability. So doing this part of the question, there's going to be sort of two possibilities. The agent could randomly choose A1, or it could randomly choose A2. So we're going to have to do both just to show the possibilities. So for this one, we can do A1 first. Now, just like I did before, I'm going to make my update rule be x equals, but this time I'm going to use the SASA update function. So QSTAT, just like before, currently at 0.15. The next bit's our learning rate over here, 0.3. Inside the brackets, we've got reward for taking the current action. So again, because we're up here, we're in S1, we take action A1, that gives us a 0 reward for the agent. Now we do this term here, our discount factor times our Q value for the next time step. So our discount factor is 0.9. And because we randomly selected to do action A1, we've got to go back over here and have a look. What's the Q value if we did action A1? Essentially, it's like we're doing action A1 again. We're in this state, we're in state 1, we do action 1, we come back to S1, but we've randomly selected to do A1 again. So we can see here the value is 0.15 again. We haven't updated it yet. So over here in our update rule, we get 0.15. And just like in the Q learning, we've got this adjustment for the current estimate. 0.15. And if we reduce this all down to a single value, we get .15. Minus 0.0045, and that will give us 0.1455. So 0.1455. So you can see that if we're in this state here, or we're trying to update this state action pair, this is the way you do it. if we've randomly selected to do A1 in the next step. So we have to do A1 first because we're updating this square. That takes us back to S1, and then our random selection comes into play, which is A1 again. So we just take this score here and discount it. That's what that middle term is. So in terms of our table, our new estimate is going to be, also just put that down to 2 figures, 0.15, and the rest of them stay the same. Now, what about if we randomly select A2 this time? It's basically the same deal. This 0.15 is still going to be the same. We've got our learning rate. Now, the reward that we get for the for RT plus 1 here is still going to be 0, because we're in state 1. We have to take action 1 because we're updating this square here. And just like before, that was a 0 reward. Put our discount factor in. But now, since we've selected to randomly take action A2 in our future step, in our next step, it's not going to be 0.15 over here anymore. This time we're going to get 3.55. And we've got the adjustment for the current estimate. Now, if I reduce this down to one value, we get .9135, and this value might look familiar from something we did previously. 1.0635. So if we randomly select A2 to be our next thing, we can see that our Q table is going to look like this. .06, and the rest of them don't change. So these are the two possible Q tables we could have depending on which action we randomly choose.